Hello guys, so we are going to continue a discussion with respect to Streamlit app. Now in this video, I'll just try to show you and project, again a machine learning project, and just to give you an idea like how easily you'll be able to create any web app with the help of Streamlit. Okay, I know you may not have seen any machine learning algorithms yet. I would suggest at least you have some idea about some of the machine learning algorithms like random forest and all. But here in this problem statement, I am going to solve a classification problem statement, right? So this is just to show you or give you an idea like how to probably develop an end-to-end project with the help of Streamlit. So first of all, I will go ahead and import all these libraries, that is Streamlit, pandas, and sklearn.datasets. And sklearn.ensemble. So first of all, I need to go ahead and install this scikit-learn. Okay, so I will just go ahead and I have to import one very important library that is called as scikit-learn, which is nothing but this is the same sklearn. So for that, I need to go ahead and install this. So here I will open my terminal and I will close this. Okay, so let's quickly go ahead and do the pip install minus our requirement.txt. So here you can see requirement.txt file is not visible. The reason is very much simple because I'm inside my Streamlit folder. So I'll just go ahead and write cd dot dot. Now let me go ahead and do the installation. So once I do the installation, my scikit-learn will get installed, and then only I will be able to use this sklearn.datasets and sklearn.ensemble. And this is one of the classification algorithm that we are going to use. Okay, so it is going to take some time till the entire installation of this particular library happens. Okay, and you always have to do this installation in your same environment where you are working. Okay, now I'm going to use this load iris dataset. This dataset has 4 important features, that is nothing but petal length, sepal length, petal width, and sepal width. So I'm going to use that. So here let me just go ahead and create one of the function. Okay, now inside this function, I have written definition load underscore data. I'm going to initialize this load iris over here. This is going to give me my data set inside this iris folder. Okay, and then I'm going to convert this into a data frame just by writing pd.dataframe, and here I have given iris.data and the column name is iris.feature underscore names. Okay, so don't worry if you are not just able to understand this right now, because later on we'll be having this detailed discussion when we discuss about all the algorithms. But in short, this is my independent features. This is my feature names, right? All the feature names, and this is my data that is available over there. Okay. Then this is my target feature, that is nothing but df of species that I've actually created, right? And then we are returning both this information over here. Okay. Let me make sure to write important decorator which is called as st.cache, and I'm writing this so that every time we load this, we should be able to save this entire data into the cache, and will not each and every time load this from this particular library. Okay, so here is my, let's go ahead and call my df comma target underscore name. So this I'm going to call it from my load underscore data. So I will just go ahead and write load underscore data function. Okay, now I'll just give you an idea over here how I'm going to apply the machine learning algorithm. So over here we are just going to apply model is equal to a random forest classifier. Okay, so I'm going to use this particular model, and this model will be requiring an input and output feature. So here, in order to train, I'll just go ahead and write model.fit, and let me just go ahead and write the df.iloc, which will be taking the independent. This is my all my independent features, and this is my output feature. Okay, so basically I'm just going to take in my x-axis all my independent feature excluding the last feature. Okay, last feature is my dependent. So last feature is nothing, it is the species, right? So this basically becomes my independent feature over here, and this will basically become my dependent feature over here. So that is the reason I'm doing model.fit. Now in order to select and make this diagram or make this application interactive, I'm going to use this st.slider, and I'm going to use with respect to sepal length, sepal width, petal length, and petal width, where my values will be between min to max, right? Whatever sepal length minimum is there, whatever sepal length maximum is there, I will be able to slide it. Okay, and I will take all this input data, whichever input data I select. Okay, I'll take the sepal length, sepal width, petal length, and petal width in the form of list, and then we will do the prediction. So here in the next step, we basically do the prediction. Okay, this is just to give you an idea what exactly we are doing. Okay, and one thing that you really need to see that, okay, it's okay if you don't understand this, but because in the later stages we'll be able to understand it, but just I really wanted to show you the power of how an application will look like. Okay, so finally we will go ahead and write down all these particular predictions and prediction pieces. Okay, so let's go ahead and execute it. So in order to execute it, again I will just go ahead and open this. You'll be able to see. Okay, let me just execute this entire application. So I'll go ahead and write cd 14 Streamlit, and let me just go ahead and run this. Streamlit run classification.py. So if I go ahead and execute this here, this is how my browser will look like. See, so this is getting loaded with respect to the data set that I have. So it says that, hey, st.cache is deprecated and will be removed soon. We can use st.cache_data. Okay, so let's go ahead and use this. Okay, so I will reload it. Okay, perfect. Now see, right now I've not selected any. Now let's go ahead and select my sepal length, sepal width, petal length, and petal width. So here you can see my predicted output is versicolor. So this is the kind of plant that I'm actually getting, right? If I go ahead and change my sepal width again, if I go ahead and change my petal length, if I go ahead and reduce my petal width, so see, it is showing setosa. If I go ahead and increase my sepal length, it is showing setosa. If I decrease my petal length, if I increase my petal width, I'm getting virginica. So how beautifully, this is just like a machine learning application, which will be in the left hand side just by with the help of slider. You're using this and just by doing this automatically, your machine learning is able to give this, right? Entire. Obviously, if you do not understand the machine learning algorithms, don't worry, we will be covering that. But the main intention of this particular video is just to show you the power of the Streamlit and show you that how beautiful this is with respect to showing the predictions, right? And here I did not write much HTML code and all. It was very much easy to probably display this entire things. And this code that you see over here, if we just see step by step, we have used components like slider. We have created this st.cache data so that it does not every time load this. Instead, it takes the cache data from there. With respect to the prediction, I have this, and we are writing that prediction in the screen itself, right? So yes, this was it from my side. I hope you like this particular video. I will see you all in the next video, but this is just an example with respect to the machine learning algorithms and how easily it will be able to display, right? So yeah, I'll see you all in the next video. Thank you.